Hi everyone, welcome to my channel. This is Leo, and let's do some more Leetcode problems today. Today's problem is called binary tree vertical order traversal. We were given the root of a binary tree, and we're asked to return the vertical order traversal of this node's value. And it should be from top to bottom, column by column. That means from left to right, okay? And if two nodes are in the same row and column, the order should be from left to right, okay? So let's take a look at the example here. So we have this binary tree rooted at 3, and the returning output should be 9, 3, 15, 20, and 7, like this. Since this is the vertical order traversal, so we're going from up to bottom. And here we got something in the same row and the same column. So for this, we should go from up to down, then left to right. So here, the answer should be 301 in this order, okay? So how do we do this? From the way it prompts, we should go from top to bottom, left to right. We naturally think of BFS, breadth first search. Okay, so we can do some breadth first search, but how are we gonna record the column of each node? We have to have a variable to record each column for each node. Okay, and the returning answer should be a list of all the numbers on the same column. Okay, so let's find out how to do this. So first, we have to make sure that we're using BFS and we're traversing from top to bottom, and we need a variable, which is the column, and we also need something to store the final result. And one way to store a pair is by using a map. We can use the column as the key and a list of integers as the value. Okay, so for example, if we have this column, we have let's say the column is 0, index is 0 here, and if you go left, it will be -1, and if you go right, it will be 1. Okay, and if we have column index 0, we will have a list of integer 3 and 15 going from up to down. Okay, so that should be all right. And let's try to walk through this. So we have a BFS, so we have a queue, and we put this root into the queue. And at this time, we put this root and its column to the queue, okay? And then we pull it out. We check whether it has left child or right child. It has both. So we add the new node into the queue, okay? And then we do BFS on this level next. At this time, we are going to record the corresponding column with the corresponding node value and save it to our map, okay? So, is there any other restrictions here? Okay, return the vertical order traversal. Okay, so it should be sorted from left to right, vertical order traversal, okay? So we have, if say root is at column 0, we should have the smallest column as the first element here, okay? All right, let's try to do this. So first, I'm gonna start a result. And if we got nothing, we're gonna simply return this result. And next, we're going to use a BFS. Okay. So in this BFS, we're not only pulling in the tree node, we're also saving its column. So we're gonna construct a data structure pair with tree node and integer. Okay, so and we're going to add our first element, new root pair, root at column index 0 into it. Meanwhile, we should have the hash map for constructing the final result. So we should have a map. Since the key is column, so it's going to be integer, and the value should be a list of integers. So we can say it's called column table new hash map. Okay. And okay, I think we're good to go. Then while the queue is not empty, we can start the BFS traversal. So the first thing is we're going to pull a pair, pull the element out. Cur. And the tree node is its key. And the column, the current corresponding column is cur.getValue. Okay. All right. So if we don't have this column in the column table, we should initialize the column as key in the hash map. So column table, put if absent column, new array list. And now since we have this column, we're going to add our current root value, or to say node value, to this list, okay, to this map. So put column, oh no, so just get and add root.value, okay. Next, if we still have children to traverse, we are going to put it into the queue, okay? So if root.left is a null, we're going to add a new pair with root.left and column -1, okay? And the same thing happens when we have a right child. Root.right column +1. Okay, so now we have this. We got the column. We saved it into our map, and yeah, I think we're good to go. Okay, last, when we're done with the queue, with the BFS, we're going to say column table dot key set. We're going to add it to our list, to our result, okay? And return result. Let's see if it works. Oh, it gives us wrong answer. Why? Oh, I think there's something wrong with the something wrong with the column index. So it's better be sorted. So we can use a tree map instead of a hash map, which is naturally sorted. Yeah, looks like the answer. Okay, so let's try the complexities. So for the time complexity, we're going to traverse through all the nodes here. Okay. And one thing that needs log n. Okay. Yeah, here. When we get it, we have a time complexity of log n to put it into our tree map. So the overall time complexity is n log n. And the space complexity should be the list of the result and the hash map, which is at most n. Okay. All right, it passed. Thank you so much for watching. I'll see you in our next video.